In this video, we will be looking at grade 10 and 11 trigonometric problems. And specifically, we are going to be looking at problems that require us to use a diagram. Now, whenever they ask you to use a diagram to help you solve a trig problem, they want you to use the cast diagram. This is technically a diagram on the Cartesian plane. But let's take a look quickly. What is the cast diagram and how are we supposed to know that we need to use it? And how do we understand it? Now, let's refer to what we should know by now. We should know that in trig, or especially in grade 10 level, with the trig ratios, we work with right angle triangles, very important, and we have a certain reference angle theta. Now from theta, if you look at it opposite, we have the opposite side. The side touching the angle is your adjacent side, and then opposite the 90-degree angle is your hypotenuse. Your hypotenuse is always opposite your 90-degree angle. And by now, we have classified sine of theta as being the ratio between the opposite side and your hypotenuse. Likewise, we have cos of your angle, which is the adjacent side over your hypotenuse. And the third important ratio we looked at was tan of theta, sorry, that's an A, tan of theta, and its ratio was opposite over adjacent. Now, in order to understand the cast diagram, you need to understand that we take the triangle mentioned, that right angle triangle, and we pop it on the Cartesian plane. The Cartesian plane discussed in depth in grade 9. And what we see now is this opposite side over here is parallel to your y-axis, which means it carries y values. Likewise, your adjacent being on the x-axis will carry an x value. So, let's go and update our trig ratios quickly. Sine will have y over something. Cos will have the ratio of x over something, and tan will be y over x. Now let's quickly discuss the hypotenuse. We need this, what we just discussed with this right angle triangle, to hold for each quadrant. Now if we had to go and draw a line, let's say in the third quadrant over here, we need the same rule to hold for that right angle triangle, and therefore the hypotenuse needs to be the same everywhere. So we will look at it as we look at the radius of a circle. The hypotenuse needs to carry the same value regardless of where it goes. And if you recall, the radius of a circle has the same length from the middle point to any point on the circumference on that circle. So that being said, our hypotenuse has now been upgraded to the letter R, which stands for radius. Sine will now be y over r. Cos of theta will be x over r. And there we have a new way of identifying the trig ratios. This is known as the cast diagram. Now the reason why it's called the cast diagram is the following. As you recall, the Cartesian plane has the center point here in the middle. And then you have positive x values, 1, 2, and so it goes on in the positive direction. And to the left of the 0 point, we have -1, -2, and so on and so forth. Likewise with y, we increase in positivity from bottom to top, and if we go down below 0, we get negative values. So we have -1, -2. Therefore, in this quadrant over here, in quadrant 1, this is known as quadrant 1, this is 2, 3, and 4. Just note I used Roman numerals to indicate that. So in this quadrant we have positive x and we have positive y. So everything in quadrant 1 will be positive. So that's all positive. Let's go over to quadrant 2 over here. Now note quadrant 2 is above the x-axis. So y is still positive, which is fantastic. However, x is negative here. We have negative x values. So if we recall, we had sine, cos, tan, and if you just help me fill in the blanks quickly, sine of theta was y over r. Cos of theta we just discussed has been x over r, and tan of theta is y over x. So if sine is y, which is a positive, and your radius is always positive. I repeat, your radius will always be positive. So we have a positive over a positive, so sine would be positive. Now if you look at cos, we have minus cos here over a positive radius, so cos is negative here. And tan Well, we have a positive y over negative x, so tan is negative. So therefore, the only thing that is positive in this quadrant is sine for an s. And now if we repeat that process in the third quadrant, you'll see tan is the only one positive in quadrant 3. And lastly, you have cos positive in quadrant 4. And now we get the cast diagram, C-A-S-T, for summary. Let's go and see how we could use this in terms of a trig equation. Okay, so we need to go and take trig ratios and put them on the Cartesian plane. Like, how are they going to ask this? So firstly, before we get to the question, let me ask you this. Can you please put 4 tan of theta plus 3 equals 0 onto the Cartesian plane? If you can, do it along. If not, well, let's do it together. What we need to do is we need to isolate tan of theta in order to get a ratio. And what that looks like is, well, we follow the inverse operations of an equation. We will take the plus 3 over, and then we'll divide 4. So 4 tan of theta would equal negative 3. And to get tan alone, we need to divide both sides by 4, because this is technically 4 multiplied tan, and the opposite of multiply is divide. So therefore we have tan of theta equals negative 3 over 4. And the cool thing about trig ratios is if we isolate this fraction, and we remember that tan is technically y over x, we have a coordinate that we can now place on the Cartesian plane. That has now appeared miraculously on the screen with my mad skills. So if you recall, on the Cartesian plane, we have something called the cast diagram. So I'm just going to write that C-A-S and T. Now, tan, we know, is y over x, meaning we have a said y value, which is minus 3, and we have an x value, which is positive 4. And if we had to go and plot that, as simple as it is, on the Cartesian plane, well, y being minus 3, remember this is 0, it's the point of intersection, so if we had minus 1, 2, and 3, so it would be somewhere in this line. And we consider x being 4, so 1, 2, 3, 4. Where these 2 points meet, we have a dot. And now we need to connect the center with that point. Okay, very important point I'm about to mention now. Whenever you draw, or whenever you write your point in, remember this was minus 3 on the y and plus 4 on the x. You close your triangle, I'm just going to use a dotted line here, to the x-axis, please. Always, do not close it to the y-axis. No, haha. It's writing haha there. Don't do that. Always close it to the x-axis because we need to measure our angle from the positive x-axis. And what we can consider here is this is a 90-degree angle. Now, we have taken tan of theta and we have successfully placed it on the Cartesian plane. Let's take it a step further. Let's see how they would ask this in a test. Now, your typical test question, homework question, and the question that follows through from grade 10 as is through to grade 11 is the following. The question will say if, then they will give some form of trig equation. Okay? So here we have if 4 tan of theta plus 3 equals 0, and then they give you something else to add direction. And I will explain what this is in 2 seconds. And so they have said just sine of theta is less than 0. This less than is very important. What is anything less than 0? It is negative. So they are saying that sine has to be negative. What does that mean? Well, if we consider our cast diagram that has magically appeared, and we have to consider where sine is negative, it would be quadrants 3 and 4. And how do we see that? Well, remember, everything was positive here. That's what the A stands for, all. And sine is positive in quadrant 2. So therefore, we need to see that they said the sine of theta is less than 0 to show us that we need to focus on either quadrant 3 or 4. Alright. Another giveaway that we need to use the cast diagram is that they have said use a diagram to determine the following. So, before we can even approach answering these questions, we need to draw the diagram. We need to literally answer their question. Now, I'm going to show you how to do this in step form. Now, the immediate place where we need to start, the first thing we look at, is we need to simplify the equation, which we did in that first illustration. We had 4 tan of theta plus 3 equals 0. And when we simplified that, we had tan of theta equals negative 3 over 4. Now, before you go on, just what I always do is I like to remind myself that tan is y over x. So you need to do the same. Just quickly write the general form of the ratio so that you can identify what your coordinates need to be. The second step is going to be that we need to draw the cast diagram and identify the quadrant we are working in. The quadrant is typically first, second, third, or fourth. Now, you'll note I've drawn a cast diagram over here. You do not need to write the CAST each time. That will not be marked. However, it is very important that you keep track of what is positive where, and especially in the beginning phase, it is important that you write it down for yourself as a guideline. Now, when we were discussing the equation itself, we saw that sine of theta was less than 0, and we discussed that that would be in the third and the fourth quadrant. So we need to look at one of these two. However, when discussing the illustration, we saw that if y is negative 3 and x is positive 4, we are working in the fourth quadrant, which means our line needs to be over here. And if you recall, I told you you need to close that line towards the x axis. Now let's write those labels in quickly. X was positive 4 and y was negative 3. Now we have labeled our triangle and we need our r. R is something that is missing. We need to complete the triangle, always complete the triangle. And in order to get your missing radius, we have a fantastic mathematical invention known as Pythagoras. Now, Pythagoras, you should remember from grade 9, says to find r squared, you say x squared plus y squared. And you will always do this at this point in the equation, whether you're looking for x, y, or r. But anyway, to get r alone, it is the square root of your x squared, which is 4 squared, plus your y squared, which is minus 3, upper bracket squared. That gives you 16 plus 9, the square root of 25, which equals 5. So your radius over here is equals to 5. And your final step is to answer your questions. Now, with this diagram, the cast diagram, you are practically unstoppable. So let's take a look here. We have cos of theta. Now cos of theta we know is x over r. What is your x value over there? It's 4. What is your r value? 5. Finished. Next one. Let's look at 10 sine squared of theta. Okay, so we're going to have 10. And now we need to replace sine with whatever its value is, and just don't forget it's squared. And sine we know is y over r. So 10 of what is y? Well, it is negative 3, and your r was 5 squared. And now you simply apply BODMAS. So let's square the bracket. That becomes positive 9 over 25. And when you multiply 10 in, we get, well, we can actually cross cancel, but let's just do it the long way. 90 over 25. And that simplified becomes 18 over 5, which equals 3 and 3 over 5. It is actually as simple as that. Ladies and gentlemen, I want to thank you for watching. Please like and subscribe. It helps us create more content. I hope you have a fantastic evening further. Bye-bye.